In this lesson, we will take an introductory look at the coordinate plane shown here. Now this plane goes by many names, including the rectangular coordinate system, the xy coordinate system, and the xy coordinate plane, to name a few. Now this plane is comprised of two axes, a horizontal axis called the x-axis that extends forever in both directions, and a vertical axis called the y-axis. Now the point where the two axes intersect is called the origin. Now an important feature of the coordinate plane is that every point in this plane has a unique pair of coordinates that defines its location. So, for example, the location of this point is defined by the coordinates 5, 3. The first number here is called the x-coordinate, and the second number is called the y-coordinate. The x-coordinate tells us the horizontal distance along the x-axis that we must travel from the origin in order to get to a given point. For this particular point, we must travel 5 units in the positive direction. Now the y-coordinate tells us the vertical distance we must travel. For this point, we must travel 3 units in the positive direction. Okay, now let's examine another point. Beginning from the origin, we must travel along the x-axis a distance of 4 units in the negative direction. From here, we must travel 2 units vertically in the positive direction. So the x-coordinate of this point will be -4, since we traveled 4 units in the negative direction, and the y-coordinate will be 2, since we traveled vertically in the positive direction for a distance of 2 units. So this particular point has the coordinates -4, 2. Okay, now let's find the location of the point -1, -5. The x-coordinate here is -1, so starting from the origin, we will first travel in the negative direction along the x-axis for a distance of 1 unit. The y-coordinate of this point is -5, so we will now travel vertically in the negative direction for a distance of 5 units. So our point is right here. This point has the coordinates -1, -5. Okay, what about the coordinates of this point? Well, beginning at the origin, we must travel 2 units along the x-axis in the positive direction, so the x-coordinate here is 2. And from here, we need not move up or down since the point is already on the x-axis. So the y-coordinate of this point is 0. Okay, what about the coordinates of this point? Well, the x-coordinate here will be 0 since we don't need to travel any horizontal distance from the origin. The y-coordinate will be 4 since we must travel vertically a distance of 4 units in the positive direction. Finally, the coordinates of the origin must be 0, 0. Okay, one last thing. Notice that the x and y axes divide the plane into 4 regions known as quadrants. This region is called quadrant 1, this is quadrant 2, then quadrant 3, and finally quadrant 4. Okay, let's summarize. In this lesson, we learned that every point in the coordinate plane is defined by a unique ordered pair of numbers, x and y. In this lesson, we will learn how to find the distance between any 2 points in the xy coordinate plane. So, for example, let's say we want to find the distance between these 2 points. We'll begin by connecting the 2 points and labeling the distance d. Now, one approach here is to extend the horizontal and vertical lines from the 2 points until they meet. Since these 2 lines must meet at a right angle, we have now created a right triangle, and we happen to have the Pythagorean theorem that relates the 3 sides of a right triangle. We can already see that the hypotenuse of our triangle has length d, and we can determine that this leg must have length 5. We know this because the x-coordinate of the first point is -2, and the x-coordinate of the second point is 3. So the distance between -2 and 3 is 5. Similarly, we can see that this leg must have length 3. At this point, we can apply the Pythagorean theorem to write 5 squared plus 3 squared equals d squared. Then we can simplify 5 squared and 3 squared, and then add them together to get 34. If d squared equals 34, then d must equal the square root of 34. So the distance between the two given points is the square root of 34. So as you can see, one strategy for finding the distance between 2 points is to construct a right triangle and then apply the Pythagorean theorem. Another strategy is to apply this formula that uses the Pythagorean theorem to create a general formula for finding the distance between 2 points. To use this formula, we simply plug in the x and y coordinates of the 2 points. So, for example, to find the distance between the points 2, -4, and 4, 0, we will first let the coordinates 2 and -4 be equal to x-coordinate 1 and y-coordinate 1. Then we'll let the coordinates 4 and 0 be equal to x-coordinate 2 and y-coordinate 2. From here, we'll take the distance formula and plug in the corresponding values. Next, we will simplify the information inside each bracket and then square -2 and -4 to get 4 and 16. Finally, 4 plus 16 equals 20, and we can simplify the square root of 20 by first rewriting it as root 4 times root 5, which simplifies to be 2 root 5. Now, of course, another way to find the distance between these 2 points is to sketch them on the xy coordinate plane, as we did in the first example. Now we'll connect the 2 points and add extra lines to create a right triangle where the sides have length 2 and 4. From here, we can apply the Pythagorean theorem to write the equation 2 squared plus 4 squared equals d squared. Next, we can simplify 2 squared and 4 squared, and then add them together to get 20. This means that d must equal root 20, which is equal to 2 root 5. Okay, let's summarize. To find the distance between 2 points in the coordinate plane, we can either apply this formula, or we can sketch the 2 points, create a right triangle, and then apply the Pythagorean theorem. In this lesson, we will learn how to graph lines. Now, if you're like most people, you probably spent some of your school years graphing lines such as these. And if you're like many people, you aren't entirely sure what the relationship is between these equations and these lines. So before we go any further, I think it's important to have a solid understanding of what it means to graph a line. Now, to set this up, I first want to talk about why we even need to graph lines in the first place. Now, as you have already seen, we can solve equations like this one. Here we subtract 5 and then divide by 2 to see that x equals 3. So this equation has exactly one solution. Here's another equation that can be easily solved, and once again we see that it has exactly one solution. We also know how to solve quadratic equations by factoring. When we solve these equations, we often get exactly 2 unique solutions. Notice that in each of these examples, the number of solutions is finite. Compare these equations with this equation. The first thing we notice here is that we have 2 variables. So we are looking for a pair of values, x and y, that satisfy the equation. Well, x equals 2 and y equals 2 is one possible solution. X equals 1 and y equals 3 is another solution, and so is x equals 0 and y equals 4. We can also have x equals 3.5 and y equals 0.5, as well as x equals 5 and y equals -1. In fact, as you probably already know, the solutions can go on without end. So how do we handle this? How do we show every possible solution to this equation? Well, that's where the coordinate plane comes in. We can take this solution and represent it with the point where the coordinates of that point are x equals 2 and y equals 2, just as in the solution. Similarly, we can take this solution and represent it with the point with coordinates x equals 1 and y equals 3. We can do the same with this solution and the same with these 2 solutions. Of course, we could add infinitely many solutions to this equation, and if we added all of them to our coordinate plane, we would get a line that extends forever in both directions. We say that this line is the graph of the equation x plus y equals 4. Now, the most important takeaway here is that this line is really comprised of infinitely many points, and each point is a solution to the equation x plus y equals 4. Now when we say that a point is a solution to the equation, we mean that the coordinates of that point satisfy the equation. So the x-coordinate of this particular point is 1, and the y-coordinate is 3. And when we take the equation and replace x with 1 and y with 3, these coordinates add to 4, which means they satisfy the given equation. So from what we know now, how do we determine whether the point 31, negative 28 lies on our line? Well, for that point to lie on the line, its coordinates must satisfy the equation of the line. When we plug 31 in for x and negative 28 for y, does this equal 4? The answer is no. So the point 31, negative 28 does not lie on the line. Okay, what about the point 15, negative 11? To find out, we'll take the equation of the line and plug 15 in for x and negative 11 in for y and see if this equals 4. Since it does equal 4, we can see that the coordinates of this point satisfy the equation, which means it does lie on the line. Okay, now let's get some practice graphing lines. We'll begin by graphing the line that corresponds to the equation y equals 2x minus 3. To graph this line, we need to find some solutions to the equation. Since the equation already has y isolated on one side, we can take our equation here and plug in values for x to find corresponding values for y. So, for example, let's say that x equals 0. If x equals 0, we can replace x with 0 and simplify to see that when x equals 0, y equals negative 3. So one solution to the equation is x equals 0 and y equals negative 3. Let's take this solution and place it in a table. From here, we'll choose a different value for x. How about x equals 2? If x equals 2, we will replace x with 2 and simplify to see that when x equals 2, y equals 1. So we have another solution, x equals 2 and y equals 1, which we can add to our table. Now when it comes to graphing lines, we really need only two solutions. However, if one of those solutions is incorrect, then the line will be in the wrong place. So it's not a bad idea to find a third solution so that if all 3 points line up, then you know that the line is probably in the right place. So let's choose one more value for x. How about x equals 4? If x equals 4, we'll replace x with 4 and simplify to see that when x equals 4, then y equals 5. So we have our third solution, x equals 4, y equals 5, which we can add to our table. Now that we have 3 solutions to the equation, we are ready to graph our line on the xy coordinate plane. The first solution can be written as a point with coordinates 0, negative 3, and this point is right here. The next solution can be placed here, and the last solution can be placed here. When we connect these points, we get a line, and this line represents all of the solutions to the equation y equals 2x minus 3. Now in this last example, the equation was already written so that the variable y was isolated. This allowed us to quickly find solutions by plugging in various values for x and then finding the corresponding y values. However, sometimes our equations will be written something like this, where one variable is not isolated. So one option here is to take our equation and isolate one variable so that we can quickly find some solutions. Another option is to plug in some nice values for one variable so that it will be relatively easy to find the value of the other variable. So for example, if we take this equation and let x equal 0, we can see that 2y must equal 6, which means y equals 3. So we already have one solution. Now notice that if we let y equal 0, then 3x must equal 6, which means x equals 2. Since we now have two solutions, we can graph our equation on the xy coordinate plane. The first solution can be written as a point with coordinates 0, 3, and this point is right here. The next solution can be placed here, and we now have enough points to sketch our line. So this is the line corresponding to the equation 3x plus 2y equals 6. Okay, let's summarize. In this lesson, we learned that when it comes to graphing lines in the coordinate plane, a line is a set of points such that the coordinates of each point satisfy the given equation. If the coordinates of a point satisfy the equation, then that point will lie on the line. And finally, if the coordinates of a point do not satisfy the equation, then that point does not lie on the line.